A tractor is an engineering vehicle specifically designed to deliver a high tractive effort at slow speeds, for the purposes of hauling a trailer or machinery used in agriculture or construction. Most commonly, the term is used to describe a farm vehicle that provides the power and traction to mechanize agricultural tasks, especially tillage. But nowadays a great variety of tasks. Agricultural implements may be towed behind or mounted on the tractor, and the tractor may also provide a source of power if the implement is mechanized. The word tractor was taken from Latin, being the agent noun of trahere, to pull. The first recorded use of the word meaning an engine, a vehicle for pulling wagons or plows, occurred in 1901, displacing the earlier term traction engine. National variations. In the UK, the Republic of Ireland, Australia, India, Spain, Argentina, Slovenia, Serbia, Croatia, and Germany, the word tractor usually means farm tractor, and the use of the word tractor to mean other types of vehicles is familiar to the vehicle trade, but unfamiliar to much of the general public. In Canada and the USA, the word may also refer to the road tractor portion of a tractor-trailer truck, but also usually refers to the piece of farm equipment. History. Traction engines. The first powered farm implements in the early 19th century were portable engines, steam engines on wheels that could be used to drive mechanical farm machinery by way of a flexible belt. Richard Trevithick designed the first semi-portable stationary steam engine for agricultural use, known as a barn engine, in 1812, and it was used to drive a corn thrashing machine. The truly portable engine was invented in 1839 by William Tuxford of Boston, Lincolnshire, who started manufacture of an engine built around a locomotive-style boiler with horizontal smoke tubes. A large flywheel was mounted on the crankshaft, and a stout leather belt was used to transfer the drive to the equipment being driven. In the 1850s, John Fowler used a Clayton and Amp Shuttleworth portable engine to drive apparatus in the first public demonstrations of the application of cable haulage to cultivation. In parallel with the early portable engine development, many engineers attempted to make them self-propelled, the forerunners of the traction engine. In most cases this was achieved by fitting a sprocket on the end of the crankshaft, and running a chain from this to a larger sprocket on the rear axle. These experiments met with mixed success. The first proper traction engine, in the form recognizable today, was developed in 1859 when British engineer Thomas Aveling modified a Clayton and Amp Shuttleworth portable engine, which had to be hauled from job to job by horses, into a self-propelled one. The alteration was made by fitting a long driving chain between the crankshaft and the rear axle. The first half of the 1860s was a period of great experimentation, but by the end of the decade the standard form of the traction engine had evolved, and would change little over the next 60 years. It was widely adopted for agricultural use. The first tractors were steam-powered plowing engines. They were used in pairs, placed on either side of a field to haul the plow back and forth between them using a wire cable. In Britain, Mans and Garrett developed steam tractors for direct plowing, but the heavy, wet soil of England meant that these designs were less economical than a team of horses. In the United States, where soil conditions permitted, steam tractors were used to direct haul plows. Steam-powered agricultural engines remained in use well into the 20th century, until reliable internal combustion engines had been developed. Gasoline-powered tractor. In 1892, John Frolick invented and built the first gasoline, petrol-powered tractor in Clayton County, Iowa, USA. A Van Dusen single-cylinder gasoline engine was mounted on a Robinson engine chassis. which could be controlled and propelled by Frolic's gearbox. After receiving a patent, Frolic started up the Waterloo Gasoline Engine Company and invested all of his assets. However, the venture was very unsuccessful, and by 1895 all was lost and he went out of business. Richard Hornsby and Sons are credited with producing and selling the first oil engine tractor in Britain, invented by Herbert Ackroyd Stewart. The Hornsby Ackroyd patent safety oil traction engine was made in 1896 with a 20-horsepower engine. In 1897, it was bought by Mr. Locke King, and this is the first recorded sale of a tractor in Britain. Also in that year, the tractor won a silver medal of the Royal Agricultural Society of England. The tractor would later be returned to the factory and fitted with a Caterpillar track. The first commercially successful lightweight petrol-powered general-purpose tractor was built by Dan Alburn, a British inventor, in 1901. He filed for a patent on the 15th of February 1902 for his tractor design and then formed Untitled Agricultural Motors Limited. The other directors were Selwyn Edge, Charles Jarrett, John Hewitt and Lord Willoughby. He called his machine the Untitled Agricultural Motor. The word tractor did not come into common use until later. The Untitled Agricultural Motor was light, powerful and compact. It had one front wheel, with solid rubber tire, and two large rear wheels like a modern tractor. The engine used water cooling by evaporation. It had one forward and one reverse gear. A pulley wheel on the left-hand side allowed it to be used as a stationary engine, driving a wide range of agricultural machinery. The 1903 sale price was £300. His tractor won a medal at the Royal Agricultural Show in 1903 and 1904. About 500 were built, and many were exported all over the world. The original engine was made by Payne and Ampco of Coventry. After 1906, French Astor engines were used. The first successful American tractor was built by Charles W. Hart and Charles H. Parr. They developed a two-cylinder gasoline engine and set up the business in Charles City, Iowa. In 1903, the firm built 15 tractors, a term with Latin roots coined by Hart and Parr, and a combination of the words traction and power. The 14,000-pound No. 3 is the oldest surviving internal combustion engine tractor in the United States, and is on display at the Smithsonian National Museum of American History in Washington, D.C. The two-cylinder engine has a unique hit-and-miss firing cycle that produced 30 horsepower at the belt and 18 at the drawbar. In 1908, the Saunderson Tractor and Implement Co. of Bedford introduced a four-wheel design, and went on to become the largest tractor manufacturer in Britain at the time. While the earlier, heavier tractors were initially very successful, it became increasingly apparent at this time that the weight of a large supporting frame was less efficient than lighter designs. Henry Ford introduced a lightweight, mass-produced design which largely displaced the heavier designs. Some companies half-heartedly followed suit with mediocre designs, as if to disprove the concept, but they were largely unsuccessful in that endeavor. While unpopular at first, these gasoline-powered machines began to catch on in the 1910s, when they became smaller and more affordable. Henry Ford introduced the Fordson, a wildly popular mass-produced tractor, in 1917. They were built in the U.S., Ireland, England and Russia, and by 1923, Fordson had 77% of the U.S. market. The Fordson dispensed with a frame, using the strength of the engine block to hold the machine together. By the 1920s, tractors with gasoline-powered internal combustion engines had become the norm. Harry Ferguson applied for a British patent for his three-point hitch in 1926, a three-point attachment of the implement to the tractor and the simplest and the only statically determinate way of joining two bodies in engineering. The Ferguson-Brown Company produced the Model A Ferguson-Brown tractor with a Ferguson-designed hydraulic hitch. In 1938, Ferguson entered into a collaboration with Henry Ford to produce the Ford Ferguson 9N tractor. The three-point hitch soon became the favorite hitch attachment system among farmers around the world. This tractor model also included a rear power takeoff shaft that could be used to power three-point hitch-mounted implements such as sickle bar mowers. This PTO location set the standard for future tractor developments. Farm tractor design, power and transmission. Tractor configurations. Tractors can be generally classified by number of axles or wheels, with main categories of two-wheel tractors and four-wheel tractors. More axles are possible but uncommon. Among four-wheel tractors, most are two-wheel drive, but many are two-wheel drive with front-wheel assist, four-wheel drive, or track tractors. The classic farm tractor is a simple open vehicle with two very large driving wheels on an axle below and slightly behind a single seat, and the engine in front of the driver, with two steerable wheels below the engine compartment. This basic design has remained unchanged for a number of years, but enclosed cabs are fitted on almost all modern models, for reasons of operator safety and comfort. In some localities with heavier wet soils, notably in the Central Valley of California, the caterpillar or crawler type of tractor became popular in the 1930s due to superior traction and flotation. These were usually maneuvered through the use of turning brake pedals and separate track clutches operated by levers rather than a steering wheel. Four-wheel drive tractors began to appear in the 1960s. Some four-wheel drive tractors have the standard too large, too small configuration typical of smaller tractors, while some have four large, powered wheels. The larger tractors are typically an articulated, center-hinged design steered by hydraulic cylinders that move the forward power unit while the trailing unit is not steered separately. In the early 21st century, articulated and non-articulated, steerable multi-track tractors have largely supplanted the Caterpillar type for farm use. Larger types of modern farm tractors include articulated four-wheel or eight-wheel drive units with one or two power units which are hinged in the middle and steered by hydraulic clutches or pumps. A relatively recent development is the replacement of wheels or steel crawler-type tracks with flexible, steel-reinforced rubber tracks, usually powered by hydrostatic or completely hydraulic driving mechanisms. The configuration of these tractors bears little resemblance to the classic farm tractor design. Engine and fuels. The predecessors of modern tractors, traction engines, use steam engines for power. Gasoline and kerosene. Since the turn of the 20th century, internal combustion engines have been the power source of choice. Between 1900 and 1960, gasoline was the predominant fuel, with kerosene and ethanol being common alternatives. Generally, one engine could burn any of those, although cold starting was easiest on gasoline. Often, a small auxiliary fuel tank was available to hold gasoline for cold starting and warm-up, while the main fuel tank held whatever fuel was most convenient or least expensive for the particular farmer. In the United Kingdom, a gasoline-kerosene engine is known as a petrol-paraffin engine. Diesel. Dieselization gained momentum starting in the 1960s, and modern farm tractors usually employ diesel engines, which range in power output from 18 to 575 horsepower. Size and output are dependent on application, with smaller tractors used for lawn mowing, landscaping, orchard work, and truck farming, and larger tractors for vast fields of wheat, maize, soy, and other bulk crops. Liquefied petroleum gas. Liquefied petroleum gas or propane also have been used as tractor fuels, but require special pressurized fuel tanks and filling equipment, so are less prevalent in most markets. Biodiesel. In some countries such as Germany, biodiesel is often used. Some other biofuels such as straight vegetable oil are also being used by some farmers. Transmission. Most older farm tractors use a manual transmission with several gear ratios, typically 3 to 6, sometimes multiplied into 2 or 3 ranges. This arrangement provides a set of discrete ratios that, combined with the varying of the throttle, allow final drive speeds from less than 1 up to about 25 miles per hour, with the lower speeds used for working the land and the highest speed used on the road. Slow, controllable speeds are necessary for most of the operations performed with a tractor. They help give the farmer a larger degree of control in certain situations, such as field work. However, when traveling on public roads, the slow operating speeds can cause problems, such as long queues or tailbacks, which can delay or annoy motorists in cars and trucks. These motorists are responsible for being duly careful around farm tractors and sharing the road with them, but many shirk this responsibility. So various ways to minimize the interaction and minimize the speed differential are employed where feasible. Some countries employ a road sign on some roads that means no farm tractors. Some modern tractors, such as the JCB Fast Track, are now capable of much higher road speeds of around 50 miles per hour. Older tractors usually have unsynchronized transmission designs, which often require the operator stop the tractor to shift between gears. This mode of use is inherently unsuited to some of the work tractors do, and has been circumvented in various ways over the years. For existing unsynchronized tractors, the methods of circumvention are double clutching or power shifting, both of which require the operator to rely on skill to speed match the gears while shifting, and are undesirable from a risk mitigation standpoint because of what can go wrong if the operator makes a mistake. Transmission damage is possible, and loss of vehicle control can occur if the tractor is towing a heavy load either uphill or downhill, something that tractors often do. Therefore, operators' manuals for most of these tractors state one must always stop the tractor before shifting, and they do not even mention the alternatives. As already said, that mode of use is inherently unsuited to some of the work tractors do, so better options were pursued for newer tractor designs. In these, unsynchronized transmission designs were replaced with synchronization or with continuously variable transmissions. Either a synchronized manual transmission with enough available gear ratios or a CVT allow the engine speed to be matched to the desired final drive speed, while keeping engine speed within the appropriate speed range for power generation. The problems, solutions, and developments described here also describe the history of transmission evolution in semi-trailer trucks. The biggest difference is fleet turnover, whereas most of the old road tractors have long since been scrapped. Many of the old farm tractors are still in use. Therefore, old transmission design and operation is primarily just of historical interest in trucking, whereas in farming it still often affects daily life. Hitches and power applications. The power produced by the engine must be transmitted to the implement or equipment to do the actual work intended for the equipment. This may be accomplished via a drawbar or hitch system if the implement is to be towed or otherwise pulled through the tractive power of the engine. or via a pulley or power take-off system if the implement is stationary, or a combination of the two. Drawbars. Until the 1940s, plows and other tillage equipment usually were connected to the tractor via a drawbar. The classic drawbar is simply a steel bar attached to the tractor to which the hitch of the implement was attached with a pin or by a loop and clevis. The implement could be readily attached and removed, allowing the tractor to be used for other purposes on a daily basis. If the tractor was equipped with a swinging drawbar, then it could be set at the center or offset from center to allow the tractor to run outside the path of the implement. The drawbar system necessitated the implement having its own running gear and, in the case of a plow, chisel, cultivator, a harrow, some sort of lift mechanism to raise it out of the ground at turns or for transport. Drawbars necessarily posed the rollover risk depending on how the tractive torque was applied. The Fordson tractors was extremely prone to roll over backwards due to an excessively short wheelbase. The linkage between the implement and the tractor usually had some slack, which could lead to jerky starts and greater wear and tear on the tractor and the equipment. Drawbars were appropriate to the dawn of mechanization because they were very simple in concept and because as the tractor replaced the horse, existing horse-drawn implements usually already had running gear. As the history of mechanization progressed, however, the advantages of other hitching systems became apparent, leading to new developments. Depending on the function for which a tractor is used, though, the drawbar is still one of the usual means of attaching an implement to a tractor. Fixed mounts. Some tractor manufacturers produced matching equipment that could be directly mounted on the tractor. Examples included front-end loaders, belly mowers, row crop cultivators, corn pickers and corn planters. In most cases, these fixed mounts were proprietary and unique to each make of tractor, so an implement produced by John Deere, for example, could not be attached to a Minneapolis Moline tractor. Another disadvantage was mounting usually required some time and labor, resulting in the implement being semi-permanently attached with bolts or other mounting hardware. Usually, it was impractical to remove the implement and reinstall it on a day-to-day basis. As a result, the tractor was unavailable for other uses and dedicated to a single use for an appreciable period of time. An implement generally would be mounted at the beginning of its season of use and removed only when the likely use season had ended. 3-point hitches and quick hitch. The drawbar system was virtually the exclusive method of attaching implements before Harry Ferguson developed the 3-point hitch. Equipment attached to the 3-point hitch can be raised aloft hydraulically with a control lever. The equipment attached to the 3-point hitch is usually completely supported by the tractor. Another way to attach an implement is via a quick hitch, which is attached to the 3-point hitch. This enables a single person to attach an implement quicker and put the person in less danger when attaching the implement. The 3-point hitch revolutionized farm tractors and their implements. While the Ferguson system was still under patent, other manufacturers developed new hitching systems to try to fend off some of Ferguson's competitive advantage. For example, International Harvester's Farmall tractors gained a 2-point fast hitch, and John Deere had a power lift that was similar to, but not as flexible as, the Ferguson invention. Once the patent protection expired on the 3-point hitch, it became an industry standard. Almost every tractor today features Ferguson's 3-point linkage or a derivative of it. This hitch allows for easy attachment and detachment of implements while allowing the implement to function as a part of the tractor, almost as if it were attached by a fixed mount. Previously, when the implement hit an obstacle, the towing link would break or the tractor could flip flip over. Ferguson's genius was to combine a connection via two lower and one upper lift arms that were connected to a hydraulic lifting ram. The ram was, in turn, connected to the upper of the three links, so the increased drag caused the hydraulics to lift the implement until the obstacle was passed. Recently, Bobcat's patent on its front loader connection has expired, and compact tractors are now being outfitted with quick connect attachments for the front end loaders, power takeoff systems and hydraulics. In addition to towing an implement as supplying tractive power through the wheels, most tractors have a means to transfer power to another machine such as a baler, swather, or mower, unless it functions solely by pulling it through or over the ground. A towed implement needs its own power source or else a means of transmitting power from the tractor to the mechanical operations of the equipment. Early tractors used belts or cables wrapped around the flywheel or a separate belt pulley to power stationary equipment, such as a thrashing machine, buzz saw, silage blower, or stationary baler. In most cases, it was not practical for the tractor and equipment to move with a flexible belt or cable between them, so this system required the tractor to remain in one location, with the work brought to the equipment, or the tractor to be relocated at each turn and the power setup reapplied. Modern tractors use a power takeoff shaft to provide rotary power to machinery that may be stationary or pull. The PTO shaft generally is at the rear of the tractor, and can be connected to an implement that is either towed by a drawbar or a three-point hitch. This eliminates the need for a separate, implement-mounted power source, which is almost never seen in modern farm equipment. Virtually all modern tractors can also provide external hydraulic fluid and electrical power to the equipment they are towing, either by hoses or wires.